jealous of you right now. Okay, guys, well, it's 5 o'clock, so that means that it's time for us to get started. So let's jump straight in there. This is the trigonometry continued from what we were doing the other day. So we managed to work through some questions where we looked at the Cartesian plane and proving an identity and a ratio in terms of a letter. So today, what I wanted us to be able to do was work on these questions where we're going to have a look at another simplification problem, a general solution, because you will definitely be given one of those. And then this first question here is something that I also want to talk to you guys about. This is part of the syllabus, and it's something that can be asked. This does come from last year's paper, so possibly it won't be asked this year, but I mean, I don't know that. I'm just saying that because they probably don't ask the same thing 2 years in a row. But that being said, I can't actually comment at all because I don't know what the examiners will do. But it could certainly come up in trials, and I think that's why it's worth us discussing. So if you do trig, any sort of matric trig, look in any sort of matric trig textbook, they will give you a long proof, and luckily for us it's not tested, on how cos A plus B is actually derived, like where it comes from. But fortunately for us, that theorem is not tested at matric level, thank goodness, because it really is quite a nasty one. But what they can ask you to do, and what they do ask us to do, is that they ask us to show how the other compound angle proofs, identities, essentially, are derived from cos A plus B. Okay, sorry, from cos A minus B. Sorry. It's cos A minus B that is the original one, and then from there everything else is derived. So they could very definitely get you. Oh no, sorry, I was correct in the first case. It is that one over there. Sorry, where my brain is right now. And then they can ask you how the others are derived. Okay, so I just wanted to go through that very quickly. And when you see me go through it, it's actually very, very simple. Okay, so in question 6.11, they want us to use the given identity, so cos A minus B, to derive a formula for cos A plus B. And this is how we would do it. Okay, so we are starting off with cos alpha plus beta. All right, and now we need to work with the sign in the middle so that we can change that. All right, so what we're going to do is we're going to manipulate what we see here, and we're going to write this as cos alpha minus beta. Okay, because a negative and a negative is going to give us this positive over here. Then what we're going to do is we're going to expand using our cosine compound angle formula. So that's going to give us cos alpha cos minus beta plus sine alpha sine minus beta. Okay, so I've just expanded it now using my normal cosine compound angle expansion. Now what I'm going to do is I'm just going to work with these negatives. So we know that cos minus beta is positive cos beta. So our first term will be positive cos alpha cos beta. And over here, what's going to end up happening with sine minus beta is we're going to end up with minus sine beta. Okay, so remember, when we're working with a negative angle, it means that our terminal arm has come to rest. In this situation here, I mean, our terminal arm has come to rest in quadrant 4. Right, so here, in this case here, and there, The terminal arm has come to rest in quadrant 4. So that's why cos minus beta reduces to cos beta, and why sine minus beta reduces to minus sine beta. Now I've got to be aware of the fact that I'm adding a negative. Remember, these two are being multiplied together, so that's going to change my sign. So now I'm going to end up with cos alpha, cos beta, minus sine alpha, sine beta. Okay, and that means that I am done. All right. Have you guys seen this at school? Have your teachers shown you these derivations that are called? Okay, so Morongo, are you saying yes? Okay. Is it making sense? Do you have any questions? But seeing there's so many of you that are saying, no, your teachers haven't shown you, what I thought I could do very quickly was show you how sine A plus B and sine A minus B are also derived, so that if it does come up, you guys are able to do that. Yeah, trig is difficult, isn't it? Hey, CK, trig is difficult. All right, so I tell you what, let's just go over to the side. Okay, you know what I'm going to do, Kanisile? Absolutely. What I'm going to do is I'm going to just scoot all the way over here. And you guys actually don't need to see that because nothing's changing for you. Let me do the two sine ones, Kanisile, and then I will come back and I will explain this again, okay? Just so that you guys have got this, all right? So this is where the compound angles are derived from, okay? So where the compound angles are derived. Okay, and then they can ask us to derive them from that original one. Okay, so let's do sine A plus B. Okay, so it is derived as follows. Okay, so here we're going to use, because it comes from cosine, so it comes from cos 90 minus A plus B, which hopefully makes sense to you if you understand your co-ratios. Okay, so that gives us the cos of, let's use square brackets, 90 minus A minus B. So that gives us the cos of 90 minus A. Actually, what we could do here, just to make life a little bit easier, hang on. Cos of 90 minus A, then cos B, and then it would have to be plus sine 90 minus A sine B. Okay, and that is where sine A cos B plus cos A sine B comes from. Okay, so that's sine A plus B. Let's talk about sine A minus B. Okay, so I'm going to do that next to it over here. Okay, so here I'm going to do sine A minus B. Okay, so sine A minus B comes from cos 90 minus A minus B, which is the cos of 90 minus A plus B. Starts to get a little bit more interesting here. So this becomes the cos of 90 minus A minus, whoopsie, beg your pardon, hang on a second, minus negative B which gives us the cos of 90 minus A cos minus B plus the sine of 90 minus A sine minus B, which then gives us sine A cos B minus cos A sine B. Okay, now I know when I did these with my second matric class, they just about had a heart attack when I showed them this. They may not ask you these. I mean, in fact, if they ask you one, hopefully it'll just be the first one. But these can be asked. Now, can you see, Leigh, you said, I don't know if you want a little bit more time to look at that or if you want to go back here. Right. Can you see, Leigh, you said you wanted me to explain something here. Where did you get lost?
Ma'am, everything.
Okay, so with these particular questions, what they're asking you to do is they're asking you to show where the compound angles come from. Okay, so in other words, why does cos alpha plus beta equal cos alpha cos beta minus sine alpha sine beta? All right, that's what they're basically asking us to do. So these are almost like proofs that you would have to study and learn. So in your exams, they do ask you to do some of the theorems where they ask you to prove things. So like in Euclidean geometry, you could be asked to prove the proportionality intercept theorem, or you could be asked to prove the similarity theorem, for example. So this is one of the proofs in the paper that they could actually ask you to show where it comes from, right? So what we're doing here is we are working with what we've got and we're relating it back to what we know. Okay, so in other words, if they've asked me to work with cos alpha plus beta, I don't have anything for cos alpha plus beta. I've got something for cos alpha minus beta, right? But I have to honor the fact that this is a plus. So I can't, so what I'm going to do is I'm going to manipulate it so that I'm writing it with a negative over here so that it's the same. Sorry, let me just use a different color here. So that it's the same rule as this one. And then I can just follow the process for that. Okay, which is exactly what we've done. All right, so we've honored the fact that this was still a plus by keeping it as a negative negative. And then I've used this rule over here that I've highlighted in green in order to be able to expand this row over here with the green next to it. Okay, so this is just expanding. All right, so in other words, all I've done, in fact, maybe what I could do is go back and go and grab it. This is where we were the other day. Hang on a second. Where did they go? It's just this, it's the exact same thing, all right? Okay, so you're just showing, can you see there? All you're doing is you're showing how we go from here. Let me just get my highlighter. How do we go from here to get that? Why does the left-hand side equal the right-hand side? So this is the process in the middle. Does that make a little bit more sense now? You understand what it is we're working with?
Yes, ma'am.
Okay. All right. So I'm just showing you why the right-hand side equals the left-hand side. And that's one of the questions that they could ask you. And now you know what they want you to do for the others as well. Okay, so for sine alpha plus beta and sine alpha minus beta, that's these two over here. That's sine alpha plus beta, and then this one over here is sine alpha minus beta. Okay, look, it is only 3 marks, so it's not the end of the world. I think what we should do now is carry on with some of the other questions, and if we've got time, we can maybe go and talk about it a little bit more at the end. Question 6.1.2 now, they are asking us to simplify completely. All right, so if we have a look at what they've given us, we've got 2 cos 6x cos 4x minus cos 10x plus 2 sine squared x. So looking at all of that, where do you think we should start, Matrix? Like, what do you think is our starting point? Anything there that you notice that you think might be significant? What do you guys think? Okay, so bearing in mind that, you know, it's probably a question that's got something to do with a compound angle or a double angle. I mean, if you have a look here, you've got cos 6x, cos 4x. What do you notice about the value 10? 10 is? If you add 6 and 4 together, you'd get 10, wouldn't you? Yeah, it's 2 times 5. Okay, but we're looking at exactly, Aisha. Okay, so 10 is 6 plus 4, right? Now, where do things with pluses and minuses start to become important to us? Okay, with compound angles. Okay, so if you've got, and I mean, this is not the full solution, but I'm just saying, if you've been given cos 10x, then you can write that as the cos of 6x plus 4x, can't you? All right, and that's significant to us because here we can see a 6x and there we can see a 4x. So the minute we've got cos 6x plus 4x, what do we have? We've got this over here, haven't we? Okay, we've got this situation. So that means that we can expand something using one of our compound angle formulae. That's where they want you to go with this. Does that make sense to everybody? That's our starting point. Okay, so you've got to be able to look at it and read the clues. The fact that there was that 10x there and the 6x and the 4x, that's not a coincidence. That's been done on purpose, right? And it's trying to draw your attention to something. Okay, so if we use that as our starting point, we can see what else emerges as we progress through the problem. Okay, so we're going to write down 2 cos 6x cos 4x. And then as agreed, we're going to write down this as cos 6x plus 4x. plus 2 sine squared x. Okay, so at the moment, we have 3 terms, all right? When we expand that cosine compound angle, then we're going to have more than 3 terms. Okay, so 2 cos 6x cos 4x. So because this is going to become more than one term, it's significant that there is a negative there. I need to keep the negative and use brackets because I'm going to have sign changes. So now I'm using this guy over here to expand what I see, all right? So I'm going to write this as cos 6x cos 4x, and cos doesn't keep its sign, so it's going to be minus sine 6x sine 4x. Everybody happy? I'm expanding according to this one over here, this compound angle over there, plus my 2 sine squared x. So what I was trying to say the other day about make sure that you're doing the correct thing algebraically, it's stuff like this, you know, where when you are subtracting a binomial, that you make sure that you use brackets, for example. Okay. So now let's see, as I said to you, let's see what else emerges. What can I say about this over here and that over there? What can I say about those two? They are what?
They are like terms.
They're like terms, exactly, Moronkoa. So because they are like terms, it means I can add them or subtract them, as is the case over here. So if I've got 2 of cos 6x cos 4x, and I take away 1 of cos 6x cos 4x, what do I have left over? Exactly, Aisha. Okay, I've got 1 cos 6x cos 4x that is left over. Does that make sense to everybody? So I'm going to end up here with cos 6x cos 4x. And when I take away my brackets, the minus and the minus means that this is going to become a plus sine 6x sine 4x plus 2 sine squared x. Okay, so now I'm looking at this and I'm saying to myself, okay, well, what's that? Okay, what are you looking at over here? The first 2 terms, I'm just going to highlight them in pink for you guys. What's this? Look at your formula sheet. It's this over here, isn't it? Can you see that? Okay. All right, so this that I've highlighted in pink, that is the expansion. So if I've got the expansion, what it wants me to do is go back and do the reversal of the expansion. So now that means that this is going to then end up being cos 2x. Careful, not cos squared x, cos 2x. Right, so one of the big mistakes that we make in matric is that the square over here ends up being a 2. Well, I mean, it is a 2, but I mean, it ends up being a coefficient of 2 rather than a square. So just be very, very careful about that. Plus 2 sine squared x. All right, so now we've got a double angle and we've got 2 sine squared x. So which cosine double angle do you guys think this question is now suggesting we use? It's dropping major hints now. Where are we going with this? We want to write this guy over here as
1 minus 2 sine squared x.
Absolutely. Again, because minus 2 sine squared x and 2 sine squared x are like terms. Okay, so if we use that, it means we can simplify further. Okay, good job, Cassandra. All right, so 1 minus 2 sine squared x plus 2 sine squared x. Okay, so As you can see, those two add up to 0, and now fully simplified, the answer would have to be 1. Okay, how was that, Matrix? How are you feeling right now? Roller coaster. It was mind-blowing. Sure, Michelle, no problem. With pleasure. Okay, so what I did here, Michelle, was I was a little bit naughty between the second line and the third line. And what I didn't show you was what was happening. But you wouldn't get marks for that matric level anyway, all right? What happened from, let me just explain this again. Okay, so let's just use a different color. So we had two, so in here, okay, so after this line ends over there, we end up with 2 cos 6x cos 4x minus cos 6x cos 4x plus sine 6x sine 4x. Oh gosh, sorry, I'm writing too close. Plus 2 sine squared x. Then these two over here, this one here and this one here, are like terms. So if I've got 2 of them and then I take away 1 of them, it means I have 1 left. So I have cos 6x cos 4x left from taking this away from this, plus the sine 6x sine 4x that I had originally. And then I'm also going to bring down my 2 sine squared x. And it's this over here, Michelle, those 2 terms together, that is your cosine angle expansion. So that's what I was trying to show you over here. Let me just move it down there. Okay, so what I've just drawn those rainbows around, Michelle, is this over here. Cos A cos B plus sine A sine B. That's what you've got. Okay, and now that you can see this, you're going to go back and you're going to do that with it. Okay, so you're going to say that cos 6x cos 4x plus sine 6x sine 4x is going to be equal to cos, all right, 6x minus 4x plus 2 sine squared x. And that is where the cos 2x comes from. Does that make sense, Michelle? And then the sum obviously continues.
Yes, ma'am.
Okay, you're happier with that now?
Yes.
Okay. All right. Okay, how are you guys feeling? Hopefully okay. Everybody strong? Breathe in, breathe out. Let's carry on going. Okay, we've got this. Don't stress. Okay, good. I'm glad, Oratile. Okay, at least if we do these difficult questions here together, it will help you with your understanding, and hopefully it'll also improve your confidence. And that when you see questions like this, you'll think about, well, you know, in our lessons, what suggestions have I heard? How should I try and approach this question? What if I tried this? What if I tried that? Don't be afraid of making mistakes. Don't be afraid of making mistakes. Take the sum, and this is why practice is so important. Just take the sum and play with it, you know. And if you try something that doesn't work, you know, go back to the drawing board and try something else. Okay, it's something that I've learned as time has gone on. being a maths teacher. Okay, good job. So can you see, Lee, this is just for you because you wanted a question on 3D trig. So we'll go through this. The 3D trig section in your paper 2 is generally not out of very many marks. You can see here last year's paper it was out of 10. So it's not really a massive section. And it's based on your understanding of the sine rule, the cosine rule, and the area rule from grade 11. Okay, so the sort of basic rule, okay, is if you are working in a right-angled triangle, okay, in 2D or 3D trig, all right, you're always going to use your basic trig ratios. So in other words, what I'm trying to say is this, okay, if you have got a diagram that was maybe sort of slightly different from that one, and you've got, sometimes you see something like this. Gosh, I really am drawing this very, very badly. Marginally better. Let's say this over here is in the same horizontal plane, okay? And this triangle at the back here is right angled, and that triangle over there is right angled. So if I call this A, B, let's call that point at the back there, that's C, and then this is D over here. If I work in triangle ACD, or if I work in triangle ACB, I'm going to use my basic trig ratios, which is SOHCAHTOA. So let's say they tell us that this angle over here is alpha, all right? And they want us to describe the length of AC. Maybe it's a pole or something like that. Let's pretend that DB is 20 meters long, all right? So if I now want to write an expression for AC in triangle ACD, all right, I see that side AC is opposite alpha. I also have the side that is adjacent to alpha. So opposite and adjacent means I have to use the tan of the angle. So the tan of the angle is side AC opposite side DC, which is 20. Do you see what I mean about your basic trig ratios? And then if you needed to make AC the subject of the formula, you would cross multiply. So AC would be equal to 20 tan alpha. Does that make sense to everybody?
Yes, ma'am.
Okay. Or for example, if they gave you, let's say they didn't tell you that this one over here was 20 and they told us that this over here was 50 and they still wanted AC. We've now got the opposite and the hypotenuse. So opposite and hypotenuse means we have to use the sine of the angle. So working with our basic trig ratios, we would say the sine of alpha is opposite AC over hypotenuse 50. So AC is equal to 50 sine alpha. Okay, so if a triangle is right angled, you use SOHCAHTOA. If a triangle is not right angled, you use the sine rule or the cosine rule or the area rule. It's that straightforward, okay? Now, when it comes to the sine rule and the cosine rule, the situations in which we can use these rules differs a little bit, okay? So this particular question that we're going to do here, we're going to use the sine rule. Now, the sine rule is used in a situation where a triangle is, first of all, not right angled. And second of all, we've got information about, I'm just trying to draw a triangle here. We've got information about an angle and a side that it is opposite from. Okay, so when I talk about opposite, if I've got this angle over here, it is opposite that side. If I'm talking about this angle over here, it is opposite this side. And this little baby angle over here is going to be opposite that side. So when we work with the sine rule, we are working in a side-side angle sort of situation, right? Now, what that means is this. Let's just get rid of, well, actually, let's just draw ourselves another triangle. Okay. So, for any triangle ABC, so up top is angle A, here's angle B, here's angle C. Side C is opposite angle C. So side AB is also called C. Okay, so in other words, AB is C. Okay, and AC is B. This is side B. And side CB is actually also little side A. Okay, so that's what they're referring to here. When they say A, they mean this A over here. They actually mean side CB. Okay, so side A over the sine of A. Can you see how we're working with the side and the angle opposite it is equal to B over sine B, the angle opposite it, is equal to C, the side over the angle sine C, the angle opposite it. Okay, so this is why I say we want a side-side angle situation, because essentially what you are doing here is that you are working with a proportion, for those of us that have done Euclidean geometry. So you're working with that. Now, let's say this is missing. You've got a side, you've got a side, you've got another angle. But you need to make sure that the angle you are trying to calculate is opposite the side that is known, and that you've got another angle and another side that are opposite one another that is also known. Does that make sense?
Ma'am, can you please repeat what you just said?
Sure, Cassandra. I'm trying to give you hints on how you know whether you're going to be using the sine rule or the cosine rule. So let's, it's so difficult to just make up stuff in case it doesn't work out. Hang on a second. Actually, you know what I should maybe do? Let me show you in the context of this question. Okay, I think it's question 8.2, right? If you have a look at all of these, let's just read this information. So T is a hook on the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane from where three people are observing the hook at T. The angle of elevation from Q to T is X. QSR is 90 plus X, that's this angle over here. QRS is X, that's this angle over there. QR is 5 units, that's this line over here. And TS equals SQ. If you have a look at all of these triangles, are any of them right angled?
No, ma'am.
No. Okay, so that means we cannot use SOHCAHTOA in this question. We're going to either have to use the sine rule or the cosine rule, depending on the information that has been given to us. All right, so now let's have a look. Prove that QS, okay, so QS is this side over here. Let's just get a brighter color. This is QS here, guys. Prove that QS equals 5 tan X. Now look, here's the 5. And there is angle X, All right. So in this situation over here, can you see 5 is opposite 90 plus x? And angle x is opposite the side that we want to work with. So here we've got, okay, it's not side, side, angle, it's side, angle, angle. This one and this one are opposite one another, a side and an angle. So a side and an angle, they're opposite one another. And this angle that we've been given is opposite the side that we want. Okay, that's how we know we've got to use the cosine rule. Sorry, sounds like all hell's broken loose outside here. Sorry, I hope that alarm going off isn't disturbing you guys. Anyway, let's carry on. Does that make sense? Cassandra, does that make a little bit more sense now?
Yes, ma'am.
Okay, right, so I'm sort of trying to show you in context, right? So in triangle QSR, we cannot use SOHCAHTOA because it's not a right angle triangle. We've either got to use the sine rule or the cosine rule. So we look at it and we say to ourselves, well, how do we know which rule we're supposed to be using? And here it's because the side that they want us to say something about is opposite an angle that is known, plus we have another angle as well as the side opposite it. So that means we've got to use the sine rule. So you will use the sine rule in a side-side angle situation or in a side angle-angle situation. Okay, so here if you've got two sides and an angle, you're going to be calculating another angle. And here if you've got two angles on a side, you're going to be calculating another side. Okay, which is what QS is. All right, so essentially we've got so this would be side little s, this would be side little r, and this would be side little q. Now we've established here that we've got two angles and one side, and what we want is another side. So it makes sense for us to put our side at the top. Okay, so we've got QS, side QS, over the sine of the angle opposite it, over sine x, is equal to, now I put a side at the top, so now in my next ratio, I must also put, sorry, my next fraction, I must also put a side at the top. So in this case, it's going to be 5 over the sine of 90 plus x. Does that make sense to everybody? So I'm subbing into the sine rule. Okay, so the A here is like this QS. Sine A is like sine x, B is the 5, and sine B is the angle at the bottom. Does that make sense, everybody?
Yes, ma'am.
I hope so, Kanyisile. I hope so. Right now, remember, I want to make QS the subject of the formula. So what I want to do is I want to cross multiply. So I'm going to multiply this, cross multiply it with that 5, so that QS is the subject of the formula. So now, guys, QS equals 5 sine x over the sine of 90 plus x is cos x. Okay, that's where our grade 11 co-ratios, our reduction formulae, we need to learn this. And now, guys, we know that sine x over cos x is tan x. Okay, and that is where 5 tan x comes from.
Oh,
Okay.
yes, ma'am.
Okay, is it making sense now?
Yes, ma'am.
Okay, and then I will do another example with you. I don't know if we'll have a chance today, but I'll do another example with you and I'll show you where we had to use the cosine rule and how it's different. So for the cosine rule, it's side, angle, side, or side, 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 but that's a discussion for another day. Okay, but I'll explain that to you. Does it making a bit more sense now?
Yes, ma'am, it does.
All right. Okay, cool. All right, so let's get this finished. Prove that the length of QT, so now let's go and find QT. Okay, so QT is this side up here. Let's highlight it in a different color. So here's QT. Okay, so they want us to prove that QT is 10 sine x. So now what we have to do, guys, is we have to ask ourselves, all right, in which triangle are we going to work? So we established that when we were working with QS, that we were working in triangle QSR. So QT is a side in which triangle?
QTS.
QTS, absolutely, absolutely. So chances are, more than likely, we are going to be working in this triangle over here, especially seeing as that we now already know something about this side, and we can see that these two sides are equal. So whatever we know about QS, we know the same thing about TS. Does that make sense? All right, so that's the triangle that we are working in. Now, what I'm going to do, I think, is get rid of myself. And I'm going to rub this stuff out. And I'm going to write here because I think that'll be a little bit easier for you guys. Okay, instead of me jumping up and down and up and down. Okay, so we know that side QS is, whoopsie daisy, is 5 tan x. We know that this side is also 5 tan x, okay? This is the side that we want. We know that this angle is x. If these two sides are equal, what can I say about that angle over there?
It's also x.
It's also x, okay, because of angles opposite equal sides. Now, how big is this angle over here that is opposite side QT? It has to be in terms of x.
180 minus 2x.
Lovely. Okay, so 180 minus 2x. Brilliant. Okay, so you see that's also not that difficult. All right, it's angles of a triangle. All right, that was a good spot. Well done, Kanyisile. And Michelle, nice, good job. Okay, so now we've got the angle opposite, we've got that side. So now again, we can use the sine rule. In fact, we could probably use the cosine rule here as well, but it'll probably be a little bit easier for us to use the sine rule. Okay, so now it doesn't matter which side and which angle we work with. Again, we're working with A over sine A equals B over sine B. If you want me to write that, I can. So sine, oopsie, we want a side, so let's put sides at the top rather. So in this case, that's S, this is T, that's Q. All right, so what we've got is side S over the sine of angle S is going to be equal to side Q over the sine of angle Q, essentially. So little side S is our QT, that's what we want. The sine of angle S is going to be the sine of 180 minus 2x is equal to little side Q, so that's 5 tan x over sine Q, so that's going to be sine x like so. Again, we can simplify something here. So the sine of 180 minus 2x, think cast diagram, think reduction formulae. This is going to reduce to sine 2x, double angle, okay, equals 5 tan x over sine x. Now what we want to do is we want to make QT the subject of the formula, isn't it? Because that's what they're wanting us to do. They're wanting us to show that QT is 10 sine x. So now again, we're going to cross multiply sine 2x with 5 tan x. So now we've got QT as the subject of the formula is equal to 5 tan x sine 2x. And this is all over sine x. All right, and now we need to use some identities. Okay, remember tan x can be written as sine x over cos x. Sine 2x can only be written as 2 sine x cos x. So let's do that. Now let's apply those identities. These are our formulae that are not known, that we have to study. So we've got 5 sine x over cos x times 2 sine x cos x, and that's all over sine x. Because we are multiplying and dividing, we can cancel. So sine cos x at the bottom with that over there, sine x over here with sine x there, or I could have cancelled this sine x over here with the sine x at the bottom, and look at what's left, guys. 5 times 2 is your 10 sine x. Okay. Everybody happy with that?
Yes, ma'am.
Okay. All right. Okay, so with the information that we had with this particular question, question 5, we could have also used the cosine rule. So we've got a little bit of time. This is only out of 2 marks. It's just literally a case of subbing into the area rule. It's very, very easy. But it is, can you see, it is actually easier than it looks. It actually really isn't that bad. But what I want to do is I just want to go back to this question that we've just answered. And I want to point something else out to you guys based on the information. All right. When you are working with the cosine rule, okay, so the cosine rule, if S was the subject of the formula, it would be S squared equals T squared plus Q squared minus 2TQ cos S. All right. When you are working with the cosine rule, all right, you can either use it in a situation where you have 3 sides. So if this side and this side and this side are known, it means you can work out the angle that is unknown. Or you can use it in a side angle side situation. Okay, so a side angle side situation is like this over here. Let me just rub all of this out again and I'll show you what I mean. Can you see that? I can see your hands up. What do you want to ask?
Ma'am, I want to ask for question 8.2, would we get the same answer if we had to use the cos rule?
Can you see you broke up a little bit there?
Would it be correct if we had to use the cos rule?
For which one? Can you see there? For 8.2.
Ma'am, for question 8.2, 2.
Shem, sorry,
Yes,
you've been breaking up.
Would
So
it
what I've
be
done, I've turned my
okay
video
if
off again. So in question
we used the
8.2,
course rule?
Nicole, can you hear what Kanyisile is saying? Because
Yes, if we
yes, absolutely. That's absolutely Kanyisile. This is what I'm busy showing you. Okay, 100%. So in 8.2, you can use the cos rule in this situation as well, because okay, what you have is a side angle side situation. Absolutely. So because you know the length of QS is 5 tan x, and you know that this is 5 tan x, you know the size of this angle over here because that was x, so you know that this is 180 minus 2x. Here is your side angle side. Here is your side angle side. So side angle side. Okay. Right, and then if you've got side angle side, it means that you can calculate the length of the side opposite the known angle using the cos rule. So absolutely, you can use the cos rule in this case as well.
Oh, okay.
All right, so no problem at all. Yeah, I mean, you would just, and then you would obviously, you would have to then go and sub into this. Okay, and then just remember that whatever you've got is squared. Okay, but yeah, give that a try. That's fine. You can certainly use the cos rule here as well. You couldn't use the cos rule for this question though, for 8.1, but in 8.2 you could have used either. And then just to finish this off, calculating the area of the triangle, they obviously want you to use the area rule. Okay, so the area rule can only be used in a side angle side situation. All right, so when I say a side angle side situation, this is what I mean. Okay, so if we are trying to calculate the area of triangle ABC, and this is the angle that is known over here, when it says half AB, see here, there's A, there's B. Do you see what I mean by side, included angle, and side? Okay, so your area rule can only be used in a side angle side situation. All right, so now if we go back here and we have a look at what they've given us, they've told us that TQR is 70. Where's TQR, guys? TQR. TQR. Okay, so that's this angle over here. Is 70 TQR. Okay, so it's the big triangle. Okay, so there aren't just 3 triangles here. The triangle that they're asking us to calculate the area of is this guy. Let me just highlight it in, I'll use bright pink. So this triangle here, the big triangle matrix. Okay, does that make sense to everybody? Okay, so this angle over here is the one that's 70. X is the one that is 25. Okay. All right. So in this case now, what are we going to do? Side angle side. So we know that this one is 70. Okay, so we've got this side over here. So we've got this angle. We need this side over here. We know that that's 5. QS, we know that that is 10 sine x. So we've got the 10 sine x over here, 70, and we've got our 5. That means we can calculate the area of the triangle because we've got a side angle side situation. All right, so what we would end up doing here is this. So the area of triangle TQR is half, that's a bracket, 10 sine x times 5 times the sine of 70. Okay, so I'm just subbing into the area rule. Okay, and now simplifying all of that, that would give us, I suppose we have to just do that on our calculator. It's not really neat. Yeah, oh look, it's only added 2 marks. So what I would do now is, oh sorry, I'm so stupid. X is 25, isn't it? So let's just write here, this would be 10 sine 25 degrees times 5 times the sine of 70. Pop that into your calculator and out comes your answer of 9,93 units squared. Okay, how was that matrix? Was it okay? Is it making sense? Cool, Cassandra. Cool, Amanda. Okay, Tato. Because that's what's given to us, Taniko. They told us it was information that was given to us in the question. Okay. Can you see there? You are always instructed to round off to 2 decimal places. Okay, unless you're instructed otherwise, but that's the general rule of thumb. Okay, cool, Mako. All right, everybody. Oh, well, I hope you enjoyed that. I hope that it helped you with your trig. We'll be starting our, it's a pleasure, Mpile. We'll be starting our next course next week. And what I'm going to be doing with you guys is the cubic function. Okay, so we'll finish off. It's a pleasure, Kanyisile. So we'll finish off calculus. Okay. Anyway, please don't forget to go and do the quiz. It's super, super important that you do the quiz this evening. If you can please fit it in, that would be really, really great. Thank you so much. Okay, so there it is in the chat. Bye-bye. Thank you. Have a lovely weekend, and we will see you guys on Tuesday.